This section is about how forces can change shapes.
Watch what happens as I sit down. Let's look at that again. At first, my weight is a bigger force than the upward force of the cushion springs, so I go down. But the more squash the springs get, the more they push back. Eventually, the force pushing back equals my weight. The forces in each direction balance, and I stay put. It's called equilibrium.
With a bungee jump, as the elastic stretches, the force in it increases until it's big enough to stop the person falling. So a force can compress a spring, but the more the spring is compressed, the greater the force it exerts in the opposite direction until it balances the force that's compressing it. A force can also stretch a bungee elastic, but the more the elastic is stretched, the greater the force it exerts in the opposite direction until it balances the force that's stretching it. If you apply a force to a spring, it will compress, but only by a certain amount. That's because the spring exerts a tension, which acts in the opposite direction to the force that's compressing it until the two forces balance. Increasing the force compresses the spring further. This increases the tension in the spring until, yet again, it balances the force compressing the spring. This continues until the spring is completely closed up and can compress no further. The same applies if a force stretches the spring. The spring extends until the tension in the spring balances the force on the spring. Increasing the force extends the spring further, which increases the tension in the spring until, yet again, it balances the force on the spring. This continues until the elastic limit of the spring is reached, when the tension in the spring can no longer balance the force pulling on it, and the spring becomes overstretched. A graph of the force on the spring against the length of the spring is a straight line. This means that the compression of a spring is proportional to the force compressing it. The extension of a spring is also proportional to the force extending it. This relationship is known as Hooke's law. As long as its elastic limit is not exceeded, when a spring is compressed or extended, it will return to its original shape. Materials that return to their original shape in this way are called elastic materials. And that applies not just to a piece of elastic, but any material that retains its shape, like rubber or a metal spring, or lycra clothes. If these materials are stretched beyond their elastic limit, they become permanently deformed and no longer return to their original shape. The elastic properties of springs are used in mattresses, kitchen scales, and suspension systems. Other materials such as wood and concrete are slightly elastic, so when they're used in buildings, they flex slightly in response to atmospheric disturbances and the Earth's movement. Plastic materials also change their shape when a force is applied, but they don't go back to their original shape once the force is removed. Clay is a plastic material. It's important to be clear about the difference between plastic and elastic materials. That's the end of the section on how forces change shapes.